given something like this, x squared equals -1. We would say there is no real number solution here, right? Because there's no real number that when you times it by itself gives us -1, right? There's no real number that when you multiply it times itself gives us -1. So in this scenario, there is no real number solution, and that's where imaginary numbers come into play. That's where imaginary numbers come into play. And so we can say, well, this is what we do say. We say the letter I is going to represent the square root of -1. The letter I represents the square root of -1. So really, we still never leave a negative underneath a radical. When we do have that negative, we now turn it into I. So we still never leave a negative underneath the radical. When we have the negative underneath the radical, we're going to turn that into I. And why is this whole true? Well, if I equals -1, then I squared, wouldn't that be the root of -1 times the root of -1, which is just -1? So what do we do when we're simplifying radicals that have a negative radicand? So let's say my directions are just to simplify. And I have the root of -16. Okay, we know this isn't a real number. So what are we going to do? We're going to split this up into -1 times 16. Can you break a radical up through multiplication? Can you split a radical through multiplication? Absolutely. Can you split a radical through addition or subtraction? Never. So this is the same as saying the root of -1 times the root of 16. Well, what's the square root of -1? We just said it. It's represented by I. And what's the square root of 16? 4. So this becomes 4I. Usually you put the real number first, then the I.
So it's like a variable.
It's like a variable, exactly. Okay, what happens when you can't simplify the number? So here I have the root of -7. I can't simplify 7, but you still can never leave a negative under the radical. So what are we going to do? This is going to be the same as the root of -1 times the root of 7, and the square root of -1 we're representing with I. So this becomes I root 7. Okay, what about the root of -12? Do you think we need to keep rewriting it into the root of -1 times the root of the number? No. What can we immediately do? We can pull out the I. So now I have I root 12. But can I simplify the root of 12? Absolutely. What's the root of 12? 2 root 3. So this is going to be 2I root 3. All right, so the first part was to simplify. Now I'm going to ask you to solve. So let's say I gave you x squared minus 5 equals 0. And I want us to solve square root method. So if we're going to solve square root method, what are we going to do? We're going to completely isolate whatever's squared. The x is squared, that's what I want to isolate. So what am I going to do? Move the 5 to the other side. Once whatever squared is by itself, then you take the square root of both sides. Now remember, we're not simplifying. Now we're solving. When we're solving, what do we have to account for? Plus minus. You got it. So x will equal plus minus root 5. It's going to be the same idea with the imaginary numbers. It's the same idea. So let's say I have x squared plus 4 equals 0, and I want us to solve. We're going to get the x squared completely by itself, so I'm going to have x squared equals -4. I move the 4 to the other side. To undo a square, we're going to take the square root. Is it okay that there's a negative? Yes, it just means our answer will be imaginary. Now, we're still taking the square root. Whenever we take the square root, what do we have to account for when we're solving? Plus minus. So this is plus minus 2i. All right, you all try this one. 2y squared plus 16 equals 0. Right, who has an answer for y? Y is equal to what? David.
Y is equal to plus or minus 2i root 2.
You got it. Y equals plus or minus 2i root 2. Anybody want to see me do this? Okay, great. All right, so a plus bi is defined as complex when a is a real number, b is a real number, and I is imaginary. And then I'm going to put a little star, and I'm going to say every number can be written as a complex number. And an example would be, let's say I have -5. Right? If I wanted to write -5 as a complex number, I need to fit the format of a plus bi, where a is a real number, b is a real number, I is imaginary. So my a will be -5, and then I can't change the value. I still need it to be -5. So b and I need to be multiplied together. So what real number do you think I'm going to make b? So when it multiplies with I, it ends up giving us nothing. So we're just left with -5. Chris? Good. -5 plus 0i, right? Because 0 times anything is 0. So -5 is the same as -5 plus 0i. I haven't changed the value. I just changed how it looked. All right. I want us to simplify. So let's say I have -3 plus the root of -4. If I have -3 plus the root of -4, I'm going to take the square root of -4 and I'm going to simplify that into what? 2i. Now, I is like a variable, okay? It is a variable. It's a variable where we know the value is the square root of -1. So we follow the rules of variables when we're adding, subtracting, multiplying, whatever we're doing. Can I add these together? No, because they're not like terms. One has a variable, one does not. So we leave it just like this. In this scenario, what number would be my A and what number would be my B? Dylan? You got it. Okay, next one. I want us to simplify -5 root -8. So we're definitely pulling that I out. So I have -5i root 8. But am I done there? No, because I can simplify the root of 8. What's the root of 8? Isn't it 2 root 2? So basically this is negative 5i times 2, and then we still have root 2. Follow the rules of variables. Can I multiply negative 5i 2? Absolutely. I'm multiplying negative 5 and 2, which is negative 10, and then we still have times I root 2. In this scenario, I want to know what my A is. I want to know what my A is and what my B is. Remember, the format is usually A plus BI. So what's the A, do you think? Matt?
A is 0.
Good. A is 0. What's my B?
B is
Negative 10 root 2. Do we all see that? Okay, great. All right, you all do this next one. I want you to simplify 2 minus the root of negative 10. All right, what do we get here? Arish? 2 minus I root 10. Excellent. What's my A? What's my A? 2. What's my B? My B, Chris? Negative root 10, because remember it's A plus BI, so this would be a negative root 10. All right, let's talk about sum and difference of complex numbers. So if I have 8 minus 9i plus 6 minus 4i. Same rules we follow for variables. Just imagine that I was an x and you guys would know how to simplify this. So we combine our like terms, which means I can add 8 and 6. 8 plus 6 is 14. Then I could add a negative 9i and a negative 4i. What's a negative 9i minus 4i? Negative 13i. We cannot combine the 14 and negative 13i because they're not like terms. Okay, let's say I have 8 minus 9i minus the quantity of 6 minus 4i. In this scenario, what do I have to do with that minus? We need to distribute it in because of the parentheses. So this is 8 minus 9i minus 6 plus 4i. Once again, we combine our like terms, so we have 8 and negative 6, which is going to give us 2. And then I have negative 9i and a positive 4i, which gives us negative 5i. Let's say I have negative 9 plus the root of negative 2 plus 6 minus the root of 18. Oh, sorry, negative 18. Okay, so before you do anything, anytime you have negatives under the radical, before you do anything else, we cannot work with the negatives under the radical, so we need to fix it. How do we fix a negative under the radical? Pull out an I. You have to do that. Before you do anything else, you must pull out an I. Can't deal with the negatives. So I have negative 9 plus I root 2 plus 6. Now, I'm going to pull out the negative from the 18, but can I also simplify that at the same time, so to kill two birds with one stone? Absolutely. So if I want to simplify root negative 18i, root negative 18, how do I simplify that? What does that become? You got it. So we have a minus 3i root 2. Now we're going to combine our like terms. So I have a negative 9 plus a positive 6 is going to give us a negative 3. Then I have I root 2 minus 3i root 2. Do we agree this is really a 1i? Hey, so same thing we do with variables, right? So if I have a 1i minus a 3i, the radicands are the same. So this is going to be a negative 2i root 2. Okay, you all do this one on your own. Negative 10 plus 6 root negative 20 plus negative 4 minus 4 root negative 5. Who thinks they have an answer for me? Arish.
Negative 14 plus 8i root 5.
How many people got that? Anybody want to see me do it? Good. Okay, great. All right, now let's talk about absolute value of complex numbers. Okay, so remember, what's the format of a complex number? A plus bi. So now when we talk about the absolute value of it, we have the absolute value of a plus bi. Refresh my memory. What does absolute value tell us? So if I'm saying what is the absolute value of 5, what is that telling us? Dylan. Good. It's the distance from 0 on a number line, right? Generally when we're talking about real numbers. But even with the imaginary numbers, it's still going to be the distance from 0. Our grid just looks a little bit different. I'm going to tell you how to find the absolute value of a complex number, and then I'll explain to you why that is. So if we're going to find the absolute value of a plus bi, what we're going to do is we're going to take the square root of a squared plus b squared, where a and b are real numbers. So if I want to find the absolute value of 2 plus 6i, if I want to find the absolute value of 2 plus 6i, remember this fits the format of a plus bi. So my a is 2, my b is not 6i, my b is 6. So if we're going to find the absolute value of this, what we're going to do is we're going to take the square root of a squared plus b squared, which will be the square root of 2 squared plus 6 squared. And that's going to be the square root of 4 plus 36, the root of 40, which ends up being 2 root 10. All right, let's talk about why this is what it is. Why is the absolute value of a plus bi the square root of a squared plus b squared? All right, so we always want the distance from 0. But now since we're dealing with imaginary numbers, we're not really having x, y. We're having real versus imaginary. And when we're finding the distance from 0 for 2 plus 6i, my 2 is my real, and the 6 is the imaginary since it's next to the I. So that means we're going to go over 2 and up 6 on the imaginary. So we're over here. And we want to find the distance from here to here. Do we agree? All right, well, how do we find the distance? Think back to geometry. We use you can use the Pythagorean theorem, but shortcut on the Pythagorean theorem is the distance formula. And if you remember, the distance formula was the root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So now we're really not doing x2, x1, we're not really doing x's and y's, we're doing real and imaginary, right? So this is 0, 0, my real is 0, my imaginary is 0, right? And then this point is 2, 6, my 2 is real, my 6 is imaginary. So here we're doing, just showing you where this comes from, we're going to do 2 minus 0 squared plus 6 minus 0 squared, which ends up giving us 2 squared plus 6 squared. Well, isn't that my a squared plus b squared? Right, this is where it's coming from. So then again, we end up with the square root of 40, which is 2 root 10. All right, let's practice this. So now let's say I ask for the absolute value of negative 4i. So remember, we want the root of a squared plus b squared. Well, how do I write negative 4i as a complex number? How do I write negative 4i as a complex number? We need it in the format of a plus bi. So what am I doing? You got it. 0 minus 4i. Do we agree that my a is 0 and my b is negative 4? Yes? Okay. So now let's plug in. We're going to have 0 squared plus the quantity of negative 4 squared, which gives us the root of 16, and that is 4. All right, you all try this one on your own. I want you to find the absolute value of negative 3 minus 4i. Matt? No, so remember, distance is always positive. All right, Brian? I can't hear you.
What is the absolute value of like just I, or like if it's constant, it's still a real number. And when it's the absolute value, of a integer is also a real number. But how come when you add it together it's wrong? Or I mean, it's still a real number either way. But how come when you add them together it's not linear?
How come when we add
So like
two imaginary numbers together it's not linear? Is that what you're asking?
Or when I add like 2 and I.
When I add a 2 plus an I?
The absolute value of I is 1, right? The absolute value of...
Well, be careful. So 2 plus I is not 2 plus 1 because it's not the absolute value. It's 2 plus the square root of negative 1. So like if we're just adding, we're not finding the absolute value. The absolute value is just telling us the distance this number is from 0. So like we can't compare just adding versus absolute values. If we added absolute values, it will always be real. Does that make sense? Okay. All right, what do we get for number 3? David. It's 5. You got it. Anybody want to see me do it? Nope. Okay, let's keep going. We're going to talk about product and quotient of complex numbers now. Okay, so if you all remember, this will help you with this unit a lot. What does I represent? The root of negative 1. So then let's talk about I squared. Well, wouldn't that be the root of negative 1 times the root of negative 1, which is negative 1? All right, what about I to the third? That's the root of negative 1 times the root of negative 1 times the root of negative 1. So it's the root of negative 1, which is just? Oh, hold on. This is negative 1 root negative 1, right? So it's negative I. Negative I, not root I. Negative I, good. All right, so then what about I to the fourth? So this is the root of negative 1 times the root of negative 1 times the root of negative 1 times the root of negative 1. So this is negative 1 times negative 1, which is 1. You will need to memorize this, okay? You will need to memorize this. All right, so now let's do some problems. Let's say I have 6i times 4i. The rules for I are the same as the rules for variables. The rules for I are the same as the rules for variables. So we're going to multiply our coefficients. 6 times 4 is 24, but you also multiply your variables. I times I is I squared. But what do we need to memorize? That I squared is really negative 1. So then this is 24 times negative 1, which is negative 24. Let's do another one. So let's say I have negative root negative 6 times 5 root negative 3. I had said this briefly before. Anytime you have negatives under your radical, can you perform any operations? No. Anytime there's negative underneath the radical, you cannot perform any operation until what? It is out of the radical. Same for multiplying and dividing. You cannot multiply when that negative is still in the radical. So you need to first rectify the negative under the radical, then you can multiply. How do we take care of the negative under a radical? Pull out an I. Pull out an I. So this becomes negative I root 6 times 5I root 3. Yes, we agree with this? Okay. So now that I pulled out the negatives. I'm not dealing with the negative under the radical anymore. Now can I multiply? Yes, now you can multiply. So I have negative 1 times 5 is a negative 5. I times I is I squared. 6 times 3 is 18. Still some work to be done, right? Start off with the I squared. What do we know I squared is? Negative 1. So a negative 1 times a negative 5 is a 5. I have 5 root 18. Am I done? No. Why am I not done? We can simplify root 18. So we're going to have 5 times 3 root 2, which is 15 root 2. Do you need to show me all those steps? No. If you can do this in your head, do it all in your head. I do not need to see all those steps. All right, you all do this one. So 5 root 10 times 6 root negative 2. All right, who has an answer for me? Ariana. I heard 60i, then root what? Root 5. You got it. Anybody need to see me do this? Okay. What about this? If I have 3 plus 2i times the quantity of 5 plus 4i, in this scenario, what do I have to do? David. We got to distribute. Yeah, we have to FOIL this out. We need to double distribute, FOIL it out, whatever you want to call it. So we have 3 times 5 is 15. What's 3 times 4i? 12i. Now we're going to have 2i times 5, which is 10i. And 2i times 4i is going to give us 8i squared. What do we need to remember? I squared is negative 1. You got it. So this is 15 plus 12i plus 10i minus 8. Combine our like terms. 15 minus 8 is 7. 12i plus 10i is 22i. All right, you all do this one. It is a dot, but a dot with I is different. Why? It is a dot, but usually when you have a plus b times a minus b, right? Generally speaking, when you have an a plus b times an a minus b, what do we end up with? A squared minus b squared. But why is it different now? Aditya? You got it, because when the two i's get multiplied together, that becomes an I squared, which is a negative 1. So it ends up becoming a squared plus b squared. I'll write it out for you, but let's just do this. Did you FOIL it out? All right, when you FOILed it out, did you end up getting 4 minus 9i squared, middle term canceled? All right, now remember that I squared is a negative 1, so this ends up becoming 4 plus 9, which is 13. So what do we need to know very well, because it's going to come up in the future? A plus bi times a minus bi, even though it is a dot, the middle term will cancel. It's not going to become a squared minus b squared. It's going to become a squared plus b squared. We need to know this. It's going to help us later on memorize this. All right, let's talk about division of complex numbers. Okay, so remind my memory, or well, refresh my memory. What does I represent? What does I represent? Nobody? The root of -1. Are we allowed to leave radicals in the denominator? No. So are we allowed to leave I in the denominator? Never. Never allowed to leave I in the denominator. So let's start off simple. Let's say I have 2 over I. I can't leave it like this. Why can't I leave it like this? Because I represents a radical. We can't leave radicals in the denominator. We can't leave I in the denominator. But what can I multiply I by to get rid of the radical? Itself, exactly. So I'm going to multiply top and bottom by I. So we end up with 2I over -1, which is the same as just -2I. All right, you all try this one. Actually, let's do this one together. All right, is 6 a problem? No. Remember, this is saying 6 times the root of -1. 6 is not the problem. What's the only problem here? I is the only problem. So am I going to multiply by a whole 6I? No, all I multiply by is I. So this gives us 5I over -6. Can I assign that negative to the numerator if I want? Absolutely. All right, let's talk about conjugates now. Oh, actually, hold on. I'm not talking about conjugates just yet. All right, what did I tell you? Any operation, before you perform any operation, what must you do? Take the I out. You might see that these are both radicals and say, I can just divide it. You can't. You will get the wrong answer. You cannot divide it until the I is out. You cannot divide it until that I is out. So this is the same as saying the root of 12 over I root 3. Now that the negative is out, now can I divide them? Yes. Now that the negative is out, now I can divide them. So if I divide root 12 divided by root 3, do you agree that's the root of 4? But what's left in the denominator? I. Is that a problem? Yes. How do I fix this? Multiply by I. Square root of 4, isn't that 2? So we have 2 over I. I'm going to multiply top and bottom by I. So we end up with 2I over -1. What is that? -2I.
Can you go back to the first part of the question?
Okay, let's talk about conjugates. So now I have 3 plus I in my numerator over 2 minus 3I in the denominator. Can I just multiply by I here? I can't just multiply by I because we're not dealing with a monomial in the denominator anymore. What am I dealing with? A binomial. So not only do I need to get rid of the I also need to get rid of the middle term because we're going to have to FOIL out. So who remembers? We did this with radicals. What are we going to multiply this by? You got it. We're going to multiply it by its conjugate, which is 2 plus 3i, top and bottom. Now remember, when we're multiplying by the conjugate with I, it's not going to be a squared minus b squared. What's it going to be? A squared plus b squared. So let me put a little star for you to remember. A plus bi times a minus bi gives us a squared plus b squared. So we're going to have 2 squared plus 3 squared in our denominator, and we're going to have to FOIL out the numerator. So in my denominator, I'm 4 plus 9. In my numerator, I'm going to FOIL this out. So we are 6 plus 9i plus 2i plus 3i squared. Let's keep going. My denominator is 13. Do we agree this is 6 plus 11i minus 3? So then we got the 6 minus 3, which is 3 plus 11i. Yes, you may. I do it on time. Okay, let's do another one. Let's say I have 2 over I plus 4 over 2 minus I. Is this an equation? No. Can I eliminate the denominator? No, I cannot eliminate the denominator. This is not an equation. I must create a common denominator. But before I create a common denominator, Arish, what do I have to do? Before I create a common denominator, what do I have to do? Good. We have to rationalize, right? We have to get rid of the I. It's okay that I'm getting rid of the I differently for each fraction. We take each fraction on its own. We rationalize the denominator. So in the first fraction, I'm going to just multiply by I. And then I'm going to end up with negative 2I. Are you guys okay with how I got that? All right. In the second fraction, what am I going to multiply by? It's conjugate, so 2 plus I, top and bottom. So my denominator is going to be a squared, which is 4, plus b squared, which is 1, all over 8 plus 4i. So I have negative 2i plus 8 plus 4i over 5. In order to add these, what must I create? A common denominator. We must create a common denominator. So now I'm going to create a common denominator of 5. So I'm going to have 5 in the denominator and negative 10i in the numerator, plus 8 plus 4i over 5. Can I now add? Yes. So remember, keep our denominator, add our numerator. So I have a negative 10i and a positive 4i, which is going to give us 8 minus 6i. I can't pull out a GCF here, but if I could pull out well, I can pull out a GCF, but if I could pull out a GCF that simplifies with the denominator, should I do that? Yeah. Since there's no GCF that simplifies with the denominator, I'm going to leave it just like this. All right, one more and then we're done. So let's say I have the root of -2 minus the root of -6, that whole quantity squared. Again, what have I been drilling this whole lesson? Before we can perform any operation, what must we do? Take care of the negatives. So I'm going to pull out an I. So this is I root 2 minus I root 6 squared. My next question for you is, can I distribute in that exponent of 2? No, this is a binomial. What do I have to do? We must FOIL. So this is an I root 2 minus an I root 6 times an I root 2 minus an I root 6. I root 2 times I root 2 is 2I squared. Yes, we agree? All right. Then I have I root 2 times a negative I root 6, which is going to be a negative I squared root 12. Keep going. Negative I root 6 times an I root 2 is a negative I squared root 12. And a negative I root 6 times a negative I root 6 is a positive I squared times 6. All right, now we simplify. 2I squared, what is that? -2. Negative I squared, what's that? Positive root 12. Negative I squared, once again, is a positive root 12. What about I squared times 6? -6. Can I simplify the root 12s? Yes, so let's go ahead and simplify them. We're going to get 2 root 3 plus another 2 root 3, and then we have the -6. Now we combine our like terms. -2 times a -6 is a -8. 2 root 3 plus 2 root 3 is 4 root 3. All right, kids, we're done.